Hello guys and welcome back to another episode of the BeamNG modding tutorial series, and in this episode we're going to have a look at the electrics JBeam section, which is used in part for the smooth light turn on and off seen on the 9 here, and also this dimming effect when you engage the starter. Before we get into that, let me explain what the electrics are. The electrics are just a bunch of information and data about the vehicle's status, input, and lights. These values are created and used by the vehicle's underlying systems, and in JBeam they're mainly used to control props, hydros, and glow maps. You can imagine them like different signal wires from a car's ECU. So what does this new electrics section do? Well, it enables us to create new electrics and apply some smoothing to them without the need of a custom Lua controller. Let's see in which part of the vehicle we put this section first. Since these electrics are going to be for the headlights, you might want to put them there in the headlight part. But that creates a problem. The problem being that you would have two different parts for the left and right headlights, and since we use the same electric here, this low beam and high beam, that as the func input for the light prop here is an electric, the low and the high beam. Since you're using the same electric in both parts, you would then have to declare that custom electric in both parts for the case where only one of them is loaded. Therefore, we're going to avoid that problem by putting that custom electric in a part that is a common parent of both headlight parts. In this case, we only have one headlight part, only the left one, but just imagine there is a second part here for the right headlight. The most obvious choice for that part is going to be the part with the main slot, because that is just always loaded. If you have another use case where you only need custom electrics in one part and one part only, you can just put them in there. Just keep in mind, if you want to have custom electrics in different parts, you need to put them into a component section. So let's first add a electrics section here. And we're also going to put that into a components section. Let's make the indentation correct. Okay, there we go. And now this just allows us to also have another electric section in a different part without them overriding each other. What this components section does is it enables us that instead of overriding the electric section with each new part that gets loaded during the loading process of the vehicle, it merges all of them together. Maybe this image can clear some things up. Here we have two parts with custom electrics, the body and left mirror. These are just examples and not actually how it is in the game. And if you don't put the electric section in a component section, then this is what will happen. First, the body part will load, and with it, the electrics from that body part. The left mirror will load after the body part, because it is lower in the slot hierarchy, and then the electrics will update to those that are in the left mirror. So the electrics that get loaded last will be the ones that the car has when it's fully loaded. If you, however, put all electronic section inside a component section each, they won't override each other and they'll just combine together. So basically that just enables you to add on to the already existing electric section in different parts. So in this electric section, we can create our new electric values in this other custom values section inside the electric section. Just going to look like this. And first of all, there's obviously a header in here. Electrics name, first argument. Then we also have electrics function. That's wrong, function. And also electrics default. There you go. We are going to make the electrics for the low beam and the high beam headlights. And I'm going to call them the low beam filament and high beam filament. That filament suffix is standard usually for those light electrics. You can also override already existing electrics, but I don't recommend doing that because some other parts might require them to be in their original state, and it just doesn't sound like a good idea. So now for the electrics function. This is a Lua expression. If you don't know, Lua, that's a programming language which BeamNG uses extensively for, well, a lot of different things, but also for this. First of all, this expression cannot contain any assignments or single equal signs, meaning that whatever, basically you put a calculation in here, and the value of this electric will then equal to whatever is calculated through this expression, this calculation that we put in here. This expression can contain numbers, all of the standard Lua operators, Lua math functions, and constants, any of the already existing electrics value just with the electrics dot prefix, and also any variable on the vehicle with the $sign prefix. There are also some whitelisted words. Those are true, false, not, and, or, nil, and DT. DT stands for delta time, and that's the time that has elapsed between this and the last frame. There are also some custom functions. Some of them, for example, are round of a value, square. There's also clamp, where you need to give 3 inputs, the value to clamp, and then the lower and upper limits. And there's also the sign. I'd say those are the most important ones. There are other ones though, and you can find a full list of all the functions available in the description. One special electric to remember is the electrical load coef. As the name implies, it's a coefficient. It scales from 1 to 0 depending on how much load is on the electrical system. I think currently engaging the starter is the only way that electrical load coef actually changes. I think it is one of, if not the most common values to multiply with, which is also what we'll be doing right here. And we just multiply that electrics with the original low or high beam electric value. The last value here is the electrics default. This is just what the electric value will return to when you reset the vehicle, or what will start off at when you first load it. You can leave this empty, which will make the value stay between resets. Although that is not advertised. I wrote advertised in the script. No, it's not advised. It's not advised to leave this empty. Usually you just want to say that 0 or whatever you want. Alright. Now we have our new electrics values that we can use as they are, but our original goal was to make that smooth turn on and off. So we're gonna use a smoother for that. This is another section in here. Alright, here we also have some this header, and here we have the parameters electrics name again. I'm just gonna copy this. Then there's also the smoother type, and the params, short for parameters, for that smoother. So we're going to take both electrics to smooth. Oh shit. So there are 3 different smoother types. Those are exponential, temporal, and temporal non-linear. The just temporal smoother is linear, but I don't really know how the temporal non-linear smoother works exactly. It's just not linear. Depending on what smoother you're using, the parameters will be different. For the exponential smoother, the parameters are in order. First, the smoothing window, which is the amount of frames that will be smoothed over. The bigger that window, the smoother the output will be. The next parameter is the starting value, which defaults to 0 if not provided. And the last one is fixed delta time, which defaults to 0.0005 in seconds, or 1/2000th of a second, aka the length of one physics step in BeamNG. I think the fixed delta time is the time between evaluations of the smoother, but the documentation doesn't say what any of these parameters mean. But here in this case, that's really the only possibility I see for that. But in this case, usually only the first parameter is used for the exponential smoother. You don't really have to bother with the other ones unless you want to. The temporal smoother have the in rate, the out rate, the auto center rate, and also a starting value. The auto center rate only exists for this linear variant, and for the non-linear one there is no auto center rate, and the third one is then just the starting value. In this case, you'll usually only use the first 2 parameters. And the in rate is how quickly new data affects the output, and the out rate is how quickly old data stops affecting the output. The bigger these rates, the higher these rates, the less smooth the output will be. Usually you make both in and out rate the same, unless you want some kind of asymmetrical behavior with your smoothing. If you want that, go ahead, try that out, experiment with that. In this case, I'm going to be using the temporal non-linear smoother with an in rate of 10 and an out rate of 10, which is basically the standard for most electrics, for lights especially. Except for brake and signal light electrics, they usually have rates of 15, so just that they switch a little bit faster. Something to keep in mind here is that some electrics already have an exponential smoother applied. And those are wheel speed, gear, A, RPM, lights, turn signal, airspeed, airflow speed. Can you open that? And altitude. Those all have a 10 frame window. And there's also fuel, oil temp, and water temp, which have a 100 frame window. And I'm going to show you that. Just watch the fuel gauge in the middle. You can see how that slowly rises up. Because of that 100 frame window exponential smoother that is applied, therefore it moves this slowly. And same thing with the water temperature here. Now that we have those electrics, I'm also going to show you how we can use these electrics to actually control the glow maps and the props of our headlights. So we're going to go to the glow map section here. And here for the simple function, first we just exchange the electrics. This is not enough though, as you might know that this is just a multiplier for this electric value. And if the sum of all the multiplied values in this bracket, here it's just 1 each, crosses the threshold of 0.0001, it will then immediately switch the material from this off material to the on material. And therefore you wouldn't see any transition, because this light would just immediately turn on, because even the smooth low beam filament electric would immediately jump above that 0.0001 threshold. Actually, I can show you that. Oh shit, it doesn't like that. Main slot not found. Alright, what's the problem here? Oh, whoops. Okay, now I can show you exactly that, right? They just immediately turn on, but what you can actually see is that it takes time for the glow map to switch back to the off material, because during that time the electric is transitioning from 1 slowly down to 0, and for that whole time basically it's above 0.001, and only as it stops the transition and it reaches 0, it actually switches back off. That's why you see that delay there. Yeah, for that reason, to make that transition actually visible, we need to specifically adjust the emissive value on this on material. And for that we have an extra argument, the material emissive scaling, where we define at what input value the maximum emissive factor of this material is reached. And here it's going to look like that. In this case it's going to be 0.49, because our input value, this right here, will transition between 0 and 0.49, and at that 0.49 we want the maximum emissive factor of the material, so that it's the brightest at 0.49. And we're going to also do that for the other material here. Alright, so let's reload that again. And now you can see it smoothly turns on and off. But that light here, the actual light, just still a one on or off switch basically. But yeah, the fix to that is pretty simple. We just go here into the headlight part and then to the props, and then here we have our low and high beam props, and we just exchange this func parameter, which is just the electric that's used here, and we just change that to filament, right? to our custom electrics value. So let's reload again. And there you go. Now those lights also smoothly turn on and off. And also what we had with the Brockwell 9 in the beginning, that dimming of the headlight when you load up the electrical system by using the starter motor. Alright, that's it for this video. Hope you guys learned something new. If you like, dislike if you didn't, and I'll see you guys again in the next episode.